We're here at an amazing AWS Energy Symposium 2024. I'm Jordan Bloom, Editorial Director with Hart Energy. I'm joined by Matt Herpich, the CEO of Conduit Power, and Oscar Tillberg, Head of Global Sales for Hitachi Energy. Thank you so much for joining us. Really appreciate it. Just to kind of get things started, before we get into the details of grid modernization, improving SCADA architecture, and much more, if you can just tell me a little bit about your companies and what you're focusing on.
Yeah, absolutely. I'll start. So my name is Matt Herpich. I'm the CEO of Conduit Power. We build power plants, simply put. And we focus on basically dispatchable energy in the Permian Basin and helping oil and gas customers that have excess supply of natural gas take advantage of that. And there's kind of two ways that we commercialize it. The first is what we call our core business or grid enablement strategy. And so the secret there is well known to everybody. It's hard to get power, right? What was a simple interconnection request for a load interconnection 4 or 5 years ago that could have been done in 10, 12 months is now taking 3-4 years, especially in the Permian Basin, because there just isn't enough power. And the Permian Basin, West Texas, is growing a lot, both in oil and gas and data centers. So our first business is we build power plants so that commercial customers can run their own operations. And the second and more interesting business is we are supplying the Texas grid with dispatchable natural gas generation and taking flare gas to do it. So we're helping oil and gas customers reduce their emissions by repurposing gas that they would typically burn on site into gas that is converted to power for the grid. So we're in an energy decarbonization fund and we're private equity backed. So we have a lot of runway.
Great. Oscar.
Hitachi Energy is a technology leader that provides solutions to utilities, independent power producers, transportation, industries, and data centers, and other consumers of powers. And now representing the utility side, provide software solution for real time to help support utilities, independent power producers, transmission, distribution utilities to basically monitor, control, and optimize the usage of electricity.
Very good. So just to tee things up, Matt, just to start things out, what challenges were you really seeking to address with the help of Hitachi and AWS? And if you want to get broad, and it's a knowledgeable audience, so if you get in as deep into the weeds as you'd like as well.
Yeah, absolutely. So as an independent power producer that builds power plants, we have two types of use cases for AWS. The first use case we have is data science and data enablement. So how do you take data, power pricing data, generation data, supply data, construction data, all this data that is out there in the public domain, and internalize that and ideate and structure commercial contracts around it. So I've been using AWS pipelines ever since I started Conduit, and even before Conduit. I was a data science and technical co-founder of a startup that was very familiar with building AWS pipelines. So that's kind of core and part and parcel with what we've been using AWS since we started Conduit over 2 years ago. The use case today, and potentially even the more relevant use case to what we're discussing now, is as part of being an operator of power generation assets, we have to remotely control those assets. So we're building a remote operating center in our office in Houston, and all of our assets right now are operating in West Texas, so in the Permian Basin. And for us to be able to control, dispatch, and manage alarming and starts and restarts, et cetera, and especially as we get integrated into the ERCOT system, we need to have a fully developed SCADA system, SCADA architecture that's built out and managed by our own control center in Houston. And that's just part and parcel with being what's called a QSC in ERCOT, or a scheduling entity. So we partnered with Hitachi because Hitachi is a leader in the space. They have SCADA systems. Network Manager product is used for many utilities. It's used for big name power companies. It's used for grid operators. And what we've loved about Hitachi is that they've treated us like a startup. And I'd say we're in the growth stage now, but at the time that we were pricing SCADA systems could be $1 million plus purchases. That's a big ticket item for a startup company, right? And Hitachi worked with us to basically price it like a startup or a SaaS solution for a developing company. So modularize and grow as we need. The part that's a little bit more innovative from the Conduit side is the architecture that supports the Hitachi system. So if you think about the Hitachi system as the software package that allows the user interface to control the alarms and the systems remotely for the actual generators themselves, that software system sits on infrastructure. So multiple servers with operating systems, networking that interacts, has open and closed IP addresses, et cetera. The typical way to deploy SCADA systems has been managed architecture. So having effectively an in-house scaled down data center with a server farm that has 8-10 servers with redundancies built in, installed the Hitachi system on those physical servers, control it from one centralized location, and then have the interactive sessions through VPN. That's also a big ticket item. Like managing hardware infrastructure for a startup business is expensive, and it costs FTEs, it costs times, it's hardware procurement, it's having system specialists. So Conduit made the decision with Hitachi's support that we're going to use AWS because we already had AWS systems in place and virtualize all of that physical architecture into the cloud. And so we deployed effectively the physical infrastructure remotely. We manage it through Terraform deployment of AWS systems, and I can leverage cloud architects and third-party contractors to defray a lot of my costs. And the beauty about this is it creates a very resilient SCADA system. So my team can manage the system, not just from our physical locations, but really anywhere. And expanding server capabilities and patching updates is really just a couple clicks of a button and redeployment through the infrastructure as a service. So it's very manageable for a startup and a young company like us to do this on the cloud. So we paired the two together.
Yeah, I mean, Jordan, we were very excited when Matt reached out to us and asked, is Hitachi prepared to work with us and enable us to do something in the cloud environment? And we've been looking for a partner in the space of utility or independent power producers to help us show that this is possible. Because up to right now, majority of the SCADA system is on-prem, which kind of puts us in a normal projection of a project that you need to specify things, you need to take consideration growth, you need to take consideration on, okay, what do you want to use in the future? So you need to, from a project implementation and duration and speed, this has put us on a different level. So we deployed to Conduit, together with Conduit, this system less than 6 months. And we don't have to worry about anything, right? We just focus on deploying the software, making sure, configure it, making sure it works for Conduit's business issues. So very exciting.
Yeah, it's an incredible acceleration for a young business like ours. A typical soup to nuts SCADA procurement cycle can be easily 12 to 18 months because you have to procure the hardware, you have to license the software, you have to install the software, you have to hire the FTEs to manage the physical hardware, you have to locate the physical hardware, you have to make sure you have enough power to supply the physical hardware. All of that in the face of an increasingly challenging weather pattern system. Over the last 60 to 90 days, my office in Memorial City in Houston, which is well within the city limits of Houston, has lost power and internet twice for extended periods. Deploying in the cloud means that doesn't stop our work. And that's critical to this. And then secondarily, cost-wise, it allows us to digest the cost on a prorated manner where it's not everything up front, huge line items for hardware procurement that the accountants have to figure out how to depreciate the whole thing and report it. We have to manage the OEM specs on it. This basically allows us to focus on just building our power desk, which is what we're good at.
Very good. Just from a Hitachi standpoint, did you want to elaborate just a little bit on how y'all customize solutions working with startups to giant players and how that fits in?
Sure. So our network manager solution, which is the family name of our software, so that software can be tailored to use for independent system operators. So many of the ISOs in North America is using our software to run the market and run the transmission network, and work all the way down to smaller cooperatives, for example, here in the US. So our software is scalable it's meant from the beginning to say, hey, we want to be able to solve big problems, but also want to make sure software can be delivered for a smaller users. So for us, when Conduit came to us and say, we want something we know we just have a few plants that we want to monitor, and said, no problem. And I think we are flexible in the way that we can, license, the way we set up things, and the way they can utilize the software, and makes it easy for our customers to use it.
Very good. I know you've touched on a bit some already, but can I get you to elaborate on just kind of what were and are the main project goals, and kind of how things have evolved, if at all, throughout the process?
Yeah. Listen, the main project goals are, I have plants in West Texas that I need to take over operations on, and I can't miss timelines. But also, being a private equity-backed company, spend and FTEs, runway of growth, all of this stuff had to be considered. And so when we went to Hitachi, so basically we licensed the Hitachi software at the end of last year, very tail end of last year. AWS has been a great partner. I went to AWS, I said, we have an existing, effectively data pipeline account with you. I need a little bit of a custom use case here where I need to have a preferred company that you recommend effectively build this mapping of servers. And AWS was already on it. They had already been looking at this for a while. They helped me through the regulatory aspect. So Conduit, as a young developer, can't afford to take any regulatory uncertainty. And so they confirmed that everything we're doing right now is, okay, given where we are. We're not at NERC high. We don't need to manage our own highly classified data centers yet. All we're really talking about here is deploying tens of megawatts remotely. So that process made me feel immediately at ease. AWS brought a regulatory person to the call. They brought a technical person to the call. They had a diagrammatic attachment that they put up on the screen. They were way ahead. Quickly, they introduced us to our unsung hero in this process, which is a third-party development AWS provider called Snapsoft. I was able to license through Snapsoft a Terraform architect, and we quickly deployed the systems. We had a 60-day window to deploy the systems, which was basically the critical path to get Hitachi to be able to even install the software. They met that timeline. So by the end of February, we were ready to configure, install, and move forward with Hitachi. Started the process in March with Hitachi of really the nuts and bolts of installing. Hitachi had a team of 4 or 5 people on it. Every week we had calls. Every week we had real-time support. This was the first time they had really done it over an AWS architecture, but it was fairly seamless. The only hiccups we ran into were configuration challenges, which are natural. Configuration you'll have in hardware and software. And effectively by the end of July, we had a working system. And so the soup to nuts timeline was met. I had to show my board that this is not a R&D project, that this is a commercially viable solution. I had a very limited internal FTE dedication to this project. I had a couple of data engineers and relied heavily on third parties. And the process, in my view, is a huge success. I don't know, what do you think, Oscar?
No, absolutely. So, I mean, this is the second time we deliver anything in the cloud. We have a distribution customer actually in Texas too. They're using our outage management system to manage, outages that sits on the cloud too. But this is the first time we're doing, SCADA on the cloud. And when we started the journey, and as Matt says, AWS has been a great partner through the process and supporting us and helping us to make sure we understand the different complexity when it comes to using the cloud, and working us to make sure there is anything from in real time, speed is important, so bandwidth, latency, making sure we're setting it up with the right expectations and the right commitments between us all. And so it's been a very exciting ride, and I think we've came out and say, this is really working, and it's something that I think others can adopt and take learnings from. So
yeah, and for my energy friends out there, they'll know what I say when I say this. When you go to a board of an energy portfolio company, oil and gas, power, midstream, etc., there's obviously a hesitancy around anything that looks and smells like tech-enabled solutions that aren't right down the middle of the fairway, right? I had a strong support from the board because I'd done this before professionally, and it to their credit, they allowed me to move forward, but they took a leap of faith. Having the easy answer is just do everything the way it's been done. So put SCADA on-prem, using physical hardware, spend the $2 million, $3 million plus dollars, hire the people to manage it. And the challenge that a small development or a small independent power producer company has like me is a $2 or $3 million check could be 50% of my annualized budget, right? So it's this mismatch of not being an R&D project and using provable technologies, but also being smart and responsible with capital. And cloud today is probably the most available system on earth. Like I talk to AWS all the time, and I ask them, in your pitch materials, what is a more available system that's commercially available for popular consumption? I don't know of one, because AWS has embedded resiliency products, so I can have multiple availability zones within the same server deployments. They have server farms and cloud data centers all over the world. So you could go US East 2, you can switch to US East 1, you can switch to US West. They have data farms in different countries, so you can diversify your geopolitical risks, right? They have embedded resiliency, physical resiliency, and as a power developer, I love this. They have backup systems on backup systems for these power centers. So, to me, it's let's embrace where we're at as a technology.
Great. You've obviously made a lot of progress in a relatively short period of time. Can I maybe get you to spell out the timeline from here, how you see things playing out?
Yeah. So, and I welcome anyone out there, if you're interested. We have an operating center in our office in Houston. We are now taking over operations. We have 25 megawatts installed reciprocating engines, natural gas reciprocating engines in West Texas. And we're taking over full-time 24/7 operations of all of those units in September. We're going through final commissioning on all that right now. And the next step is grow. So the beauty of doing this on the cloud and with Hitachi is, if I build another plant, it's really a systematic process. All they need to do is add endpoints in our SCADA system. And all we need to do is basically have a plant control system hooked up in the field, which we're gonna have anyways. And they need to be integrated, and voila, you have another operating plant within the same architecture. So to me, next step is grow my company. I want to be 200, 300, 400 megawatts of natural gas power supplying the Texas grid in the next 12, 24 months, and working with oil and gas companies to do it. So that's what I see.
Yeah, for us, thanks to Matt, we're using his voice, in terms of communicating and explaining and removing some of the magic, I think, that comes with the cloud when it comes to, independent power producer utilities, where there's some hesitance to take that leap and trust it. Because if you look back, it's a long history of using this software on-prem, and so we're using Matt to kind of promote and explain and make sure that remove some of the boundaries that I think people believe exist when in reality they don't, right? Because I think, as Matt say, you have a more reliable, infrastructure, and you can get the commitment from AWS, from performance, from anything, and I think that's something people should take advantage of. So for us now, we're in the beginning of a journey where I think we're going to see more and more customers in this space migrating to a cloud solution versus on-prem.
And one thing I'd emphasize is, and this is more tailored to my energy cohort, is my data engineering team have an oil and gas background, which is, I hear a lot of times from traditional oil and gas or traditional energy companies, we don't have the experience in-house. Well, the labor force is reskilling itself. My data engineers came from data processing of 3D seismic, which oil and gas companies know all too well. You don't need a huge leap of technology. If you're already doing AWS architecture, AWS pipelining in-house, this is just a natural extension of that. And so it really is the step function to get from traditional on-prem physical into cloud deployed, best-in-class tech-managed software isn't that high. And the city of Houston is ground zero for this. I'm seeing my team is continually recruiting for data engineers and tech talent, and we've hired my 2 data engineers on my team right now, both came from oil and gas. One came from a third-party seismic processing company, and one came from a major. And they cut their teeth on data pipelining and data warehousing at these companies. And when they came to us, they repurposed their ability to stand up EC2 servers and S3 buckets into forming that baseline architecture of putting a software system on top of it at scale. And it's been beautiful to see because I have high hopes for the energy tech community in the city.
Now, what also is exciting, Jordan, is that this will enable Conduit and others to focus on what they do best, which is running the business. It will help them, support and making sure the system is available together with AWS, and I think that's the benefit. You can reap, your resources you have, instead of having them there to service and maintain the software, it can be there to be available to do other tasks that is more beneficial for Conduit, for example. So.
Very good. Just curious, you're obviously focused on a lot of room to grow in West Texas. But the Permian's huge. Are y'all looking at the New Mexico side as well? Because that's a different grid. So.
Yes, we are. I have an interesting. So we have a whole, obviously investor deck out there, and one of the most where there's 2 really interesting slides that we've added in the last, call it 30 days. The first slide is, and I'm sure you know this, but many people out there don't. Do you know what's projected to be the single largest natural gas basin in the United States by 2026? The Permian. And it's all associated gas. So you have an oil basin throwing off more gas than the Marcellus by 2026. So the systemic disconnect between natural gas supply and what will be the nation's largest natural gas basin and the ability to use that gas in basin is growing and widening. And some of that, of course, is New Mexico. And the second interesting slide we've just added is ERCOT, and I encourage everyone out there, ERCOT just put out a Permian Basin Resiliency study where they've taken a look over the next 10, 15 years at what they call Load Zone West, but it's really Permian Basin and the growth. Load Zone West, Permian Basin, is projected to be relatively the fastest growing load zone in the state. There's about 20 gigawatts of demand out there right now on an 80 gigawatt market, and they're anticipating that's going to double, and about half of that is going to be oil and gas, and about half of that is going to be data centers. So you have the fastest growing region in the US with the fastest growing supply in the US of dispatchable energy. To answer your question about New Mexico is a different regulatory framework. It's under what's called the Southwest Power Pool, or SPP, not ERCOT. We have a variety of partners. So we have a joint venture partner, Riley Permian, that has a big asset in Artesia. So we're working with them to try and solution around how do you come up with in-basin load in New Mexico to support growth? Because right now, the interconnection timelines for Southwest Power Pool to sell gas into merchant are very long, 3, 4, 5 years. And the problem is urgent. So the Delaware Basin producers are curtailing production right now because there's not enough natural gas. Now, midstream companies are expanding facilities, but we're talking with those same midstream companies about how do you remarket the gas, because you can't just all go to the ship channel, right? I think the single biggest solution for the state of New Mexico right now is to capitalize on data centers. And so we're working with oil and gas customers, both upstream and midstream, to try and bring this tech revolution, and I don't mean AI, I mean anything, really, cloud-hosted storage, cloud-hosted compute, crypto, all of it, into that state. It could be the biggest money-making opportunity for the state in a long time. So whereas in Texas, we're primarily focused on dispatchable generation into ERCOT, in New Mexico, we've been hyper-focused on building effectively a in-basin load solution using tech.
It's really interesting. Well, lastly, I just wanted to see if there was anything else you wanted to highlight about your companies or about the future of grid demand in general.
It's a very exciting time to be in power. So I was an electrical engineer undergrad, and I was right before the data science revolution. And I remember people telling me, you're going to be deprecated in 5 to 10 years. No one cares about hardware. Everyone cares about software. And now my team is hiring electrical engineers by the tens. And every person I talk to on the street has some conception of what ERCOT is, of what Centerpoint Encore are, or what utilities are. Everyone has a statistic about data, compute, the venture capital companies of the world are starting to buy energy, traditional energy. Amazon itself is buying nuclear facilities. Power is very much in vogue. I came from a tech startup. I sold my last startup to a tech startup, and I saw the excitement from the 22 to 28-year-olds in joining an energy tech company, an energy tech revolution that I hadn't seen in years of looking at renewable power. And so to me, power is probably top 2 or 3 in terms of important sectors in the United States in the next decade, maybe short of healthcare. And the technology is so advanced that we have very resilient tech-enabled solutions that are distributing power generation from these centralized plants that were built 40, 50, 60 years ago into effectively making everyone a grid participant, both on a buy and sell side. And that is something that is irreversible. And that's also the way for us to have a modernized, resilient system. Combine that with an increasingly unpredictable weather pattern and challenges around maintaining the grid. To me, it's the most exciting sector. We need partners like Hitachi and AWS to enable the growth. We need all hands on deck in terms of thinking. And no matter where you stand on the debate around the right solution for the grid long term, be it renewables, be it dispatchable, be it nuclear, we can all agree that the demand for power has rapidly exceeded anyone's forecast. And so I've just really enjoyed the energy in the sector.
Yeah, I'll just add to Matt. I think for us as a technology provider, we're here to make sure we provide value to our customers, and the changes that's happening now is so fast. You see back in a rearview mirror, you have, looking back, you have customers that are installing our software, they run it for several years, and then, after 4 years, they're upgrading it, then run for another 4 years. That's not gonna make things work for our customers moving forward. So time to value, making sure we provide software that is not only quick to deploy, easy to make sure you adapt new functions and features. So for us, we've already started that journey, and now Conduit is an example where we deployed our software network manager in a very fast, but also making sure we can enable when Conduit needs new functions to support their business. We're there to just fast upgrades and just adding on those functions and features and using AWS technology. So starting a new journey for us as a vendor, where now we're going to go to continuous upgrades versus you get before is an upgrade after 4 years, and it's a big project. Right now is just smaller. You agree that hey, now we're going to go to a new version, and it's fast, and it's with very, very limited interruption for our customers, for the operations. So it's very exciting.
And the sector has changed when myself and other energy entrepreneurs in the sector have budgets around technology-enabled solutions that aren't viewed as back office IT anymore. They're viewed as strategic. And I'm seeing that over and over and over again.
Great. Well, no, thank you so much for being here. Really appreciate your insights. Very fascinating. Thank you so much, everyone, for joining us at the AWS Energy Symposium 2024. Have a great rest of the day.